Let's talk about orders of magnitude. Did you know you can't just make a picture of anything? Take a map of the world, for instance. Well, your house is somewhere on that map, right? Why can't you see it? Well, obviously it's too small. You might see it on a map of your city, but a map of your city won't show someone else's house in another country across the world. What if you wanted to make one map big enough and detailed enough to show both houses? How much paper would you need? And when you were done, how would anyone use it? Totally unfolded, would it even fit indoors? Okay, suppose you unfolded it outdoors. Standing on one side, a person could see the mark representing your house. But could they see the detail on the other side? Okay, suppose they climbed onto something tall to see the whole map at once. Well, now they're too far from either side, and they're no better off than if they had looked at a world map they could hold in their hand. You see, we're back where we started. There's a fundamental problem with size and scale. Human faculties can only grasp a certain range of magnitudes at one time, even if other magnitudes are accessible. A picture can easily have so much detail that nobody can see it, and if they zoom in far enough, they can easily get lost in relation to the picture. There's no solution to this problem. We are not God, and we have limitations we will always have to work around. There's a reason the word astronomical can mean big beyond comprehension. Any portion of outer space is inevitably outside the range of our immediate faculties. We have enough trouble truly grasping the size of just the Earth. The orbits of most man-made satellites follow invisible circles, or ovals, that are between 2 and 5 times larger than this, but most satellites are no bigger than a person. It's the same old house versus world problem, except over 5 times worse. That's why you never see satellites in photos of the Earth. And a photo of the entire solar system? Pfft, forget it! It would just look blank. You would need a microscope to see the planets, and that's if the photo had infinite resolution and no noise. And if you could find them. It blows me away when flat earthers grumble about not having photos of these things.
Nobody's ever seen that. We've never seen a photograph of it. Nobody's ever seen the solar system like this. It's always graphics. It's always secondary knowledge.
What do they expect? We are not God, and that kind of primary knowledge in the heavenly realm is completely impossible. I've seen 2 separate flat earthers complain about this moon time-lapse from NASA's Discover satellite. This is so sad, because one of them actually says,
"Very few people understand how the moon works on the heliocentric model."
Then proceeds to question its authenticity using essentially sheer nonsense.
If this moon is traveling this far while these pictures are being taken, guess what? This was more than just a little afternoon with a quarter turn of Earth or however far it moves here.
What does he mean by this far? Does he honestly think these photos show the moon completing a quarter or half of its orbit just because it passes that much of the Earth's surface in the camera's vision? That logic barely parses. Very few people understand, huh? Well, he's not one of them. This goes back to size and scale. These photos show the moon roughly 3/4 of the way from the camera to the Earth. But what is that distance compared to their size? He seems to think there's like 1 or 2 Earth radii between them, which couldn't be more wrong. These photos were taken from 1 million miles away. That's 250 Earth radii. The viewing angle is half of 1 degree, comparable to that of a high-end super telephoto lens. The full circle the moon will travel stretches hundreds of thousands of miles outside the frame on either side. This is a tiny portion of that circle. These numbers are very far outside our everyday experience, and they are difficult to comprehend. But the math works out, and the photos are real.